Hello everyone, I am Santosh KG, Assistant Professor, Department of Mechanical Engineering, MIT, Mysore. In today's session, I am going to solve some problems on the topic projection of planes, which comes under Module 2 in the subject Engineering Graphics, having subject code 18EGDL15/25. The given problem statement is like this: draw the projection of circular plate with negligible thickness of 50 millimeter diameter resting on HP on a point on the circumference. Full stop. The plane is inclined at 45 degrees to HP and the top view of the diameter passing through the resting point makes 60 degrees to VP. So, by reading the problem, first let us try to write down the data. The data given is, we are having a plane which is a circular plate. So, the given plane is a circular plane, or we can call it as a circular lamina, and it is having 50 millimeter diameter. So, the diameter of the plate is 50 millimeters. Then they say that the plate is resting on HP. So, the given condition or the plane on which this circular lamina is resting is HP, and it is resting on a point. Then the plane is inclined at 45 degrees to HP. So, the inclination of the circular lamina is 45 degrees with respect to HP. So, this represents the surface inclination of the circular lamina, and the top view of the diameter. The other condition given is the top view of the diameter passing through the resting point, it is making an angle of 60 degrees with VP. So, the top view of the diameter, it is making 60 degrees with VP. So, first by reading the problem, we have noted down the different data given. So, this is the circular lamina we are having. So, the circular lamina, it will be having a circular shape, and the diameter of the circular lamina given is, it is having 50 millimeter diameter. ನನಗೆ ಅದು ಇದು ನಿಂತೋಯ್ತು. ಹಾಂ ಹಾಂ ಸರಿ, ಓ ದಾರ, ಹಾಂ ಸರಿ ಇರೋದು, ಥ್ಯಾಂಕ್ಸ್. ಬಾಕ್ಲು ಮುಂದೆ ಬಿಟ್ಕೊಂಡು ಹೋಗು. Once you note the data, now let us try to solve the problem. So, the given lamina is a circular lamina. The circular lamina will look like this, and it is having the negligible thickness, and it is having certain amount of diameter. So, first we need to place the circular lamina either on HP or it should be placed on VP. So, the given condition is the circular plate of 50 millimeter diameter is resting on HP. So, first we need to place the circular lamina on HP, as we know that the line XY, it divides vertical plane and horizontal plane, and below the line XY it represents the horizontal plane, and above the line XY we have the vertical plane. So, since the given lamina is resting on HP, so first I should write or place the lamina in HP. So, when a given lamina is placed on HP, we can see its top view. So on the top view, the lamina will look like a circle, and when you see it from the front, it looks like a line in the front view. So first I am going to write the lamina by placing it on HP. So when I place it on HP, so the top view will look like a circle. After writing the top view of the circular lamina, now let us see how this circular lamina is going to look when we see it from the front. So when the lamina is placed on HP like this, so if you look from the front, the lamina will look like a straight line, and the length of the line will be equals to its diameter. So in order to write its front view, what I need to do is I need to project the circumference, the points on the circumference to get its front view. So the front view, it will look like a line. But here you can see that if I take a circle, it is not having any corners. So if a given lamina is not having any corners, then it is difficult to reproduce the lamina in the second position as well as in the final position. So in order to reproduce the circular lamina in second and final position, what we are going to do is we are going to divide the circle into some number of parts. We can divide the circle into either 4 parts, or we can divide the circle into 6, 8, 12 like that. More is the number of parts, the accuracy of the drawing which you are going to reproduce in the second position and the final position, it will be more. But when you try to do the number of divisions, when you increase the number of divisions, the problem is in order to produce reproduce the diagram in second and final position, it requires more amount of time, and also it leads to little confusion. So to avoid the confusion, as well as in order to have the proper shape in the second and final position, let us divide the given circular lamina into 8 parts. So how we are going to divide the circle into 8 parts? So from the center, first draw one horizontal line, which is a light line because it is not present in the lamina. Similarly, from the center you draw one vertical diameter. So these two lines also, it should be very light. So if I write any lines in a pink color, it means that they are construction line and they are drawn just to reproduce the diagram in the next positions. So here it is having only 4 divisions. In order to divide this circle into 8 parts, I will take this horizontal line as a reference, and I am going to place the protractor at the center. So by placing the protractor at the center, I am going to mark a line point at an angle of 45 degrees. Similarly, by taking this 0 as a reference, again I am going to write or mark a point at an angle of 45 degrees. Thereby I get 2 points, one point at an angle of 45 degrees which is measured in counterclockwise direction, and other point it is also at an angle of 45 degrees with respect to horizontal, but it is measured in clockwise direction. Now I am going to join the center of the circle to this point, and I am going to extend that line. So this line represents a line which is inclined at 45 degrees to this horizontal line. Again I am going to extend this line in the backward direction. Similarly, by keeping the scale at the center and aligning the scale along this point, I am going to write one more diameter. So, this diameter is inclined with respect to this horizontal line at an angle of 45 degrees. Now, you can see that the given circle is divided into 8 parts: 1, 2, 3, 4, 5, 6, 7, 8. For my reference, what I am going to do is, I am going to name certain points on the circumference of the circle where these lines are meeting the circle. So, first I am going to write a point A over here, then where this line is meeting the circumference of the circle, there I am going to mark point B. Similarly, where this vertical diameter is meeting the circle, I am going to write that point as C. Similarly, this line where it is joining the circumference, there I will mark point D and I will continue like that. So, I will get the points A, B, C, D, E, F, G and H. So, in total we are having 8 points, and I am going to write the front view of these points. So, in order to get the front view of these points, what I should do is, I need to project, or I need to draw the projectors passing through B and H. Similarly, I need to write a projector which is passing through C and G, and also I need to write a projector which is passing through D as well as F. And if you see carefully, if I draw a projector from point B, it will also pass through the point H. Similarly, if you draw a projector which is from D, it will also pass through the point F. So, it means that B and H, they are on the same vertical projector, D and F, they are also on the same vertical projector. Now, if you see this lamina from the front, this point A is along this point, this position. So, I am going to name it as A dash. Similarly, when you see the lamina from the front, the point B is in the front and H is exactly behind it. So, the point B is visible in the front view, whereas the point H, which is exactly behind B, it is not visible. So, I am going to write it in a bracket. Similarly, when you see the point C from the front, its front view will be C dash, but if you look at the point G, it is exactly behind point C, so it is not visible. Therefore, I am going to write the point G dash inside the bracket. The point D, it is visible, whereas the point F, which is exactly behind it, it is not visible. This is the point E, so I am going to write point E dash, which represents the front view of the point E. Now, this line A dash, E dash, it represents the front view of the lamina which is resting on HP. When the lamina is kept on the horizontal plane, the shape, the original shape of the lamina can be seen by seeing from the top. So, the top view is visible in the horizontal plane which is below XY line. Similarly, when you see the lamina from the front, it looks like a line and the line will be visible in VP. So, the front view of this lamina is a straight line and the top view of this lamina is a circle. So, thereby we satisfied the condition that the circular lamina is resting on HP. Now, let us assume that the lamina will be resting on point A. Then we need to satisfy the other condition that the lamina, it should be inclined at 45 degrees to HP. So, since the lamina is resting on HP, so to give the inclination to the plane, I should lift the plane. So, when I lift the lamina, the angle that it should make with respect to the horizontal line, it should be 45, and we can see the amount of inclination of the plane with respect to horizontal line in the front view. So, in the front view the lamina is looking like a line, therefore what I am going to do is I am going to incline the front view of the lamina, which is a line, at an angle of 45 degrees, such that the point A is on XY line. So, if the point A dash is on XY line, it means that the lamina is resting on the point A dash. So, first I will mark the point A dash, then I am going to keep the protector at point A dash, then I am going to mark a point at an angle of 45 degrees, and along this line I am going to write a construction line. So, the construction line is drawn between the 2 points. One point is A dash and other one is a point which is marked at an angle of 45 degrees. So, this is a construction line. So, along this line I should place the line A dash E dash, such that A dash should be on XY line. We know that the length of A dash E dash is this much. We can measure it by means of a compass. So, by using a compass, place one end of the compass at A and the other end at point E. So, it is having this much length. Again what I am going to do is I am going to place one end at point A dash and I am going to draw an arc along this a construction line. So, when I draw a arc on this line, so this length will be the length A dash E dash in the second position. So, if I join these 2 points, I will get the front view of the circular lamina in the second position, and it is inclined at an angle of 45 degrees. So, this line, it is making an angle of 45 degrees with respect to horizontal. Now, on this line I am going to reproduce the points B dash of H dash, C dash of G dash and D dash of F dash. So, in order to reproduce these points on the front view, again I will make use of the compass. I will measure the distance of B dash H dash from A and I am going to mark a point or an arc on this line. Again I will measure the distance of C dash G dash from A and I am going to reproduce it along this line. Similarly, measure a distance of the point D dash of F dash from A and mark it over here. We get 3 points. So, the first point, which is next to A dash, it represents B dash of H dash, and the next point to B dash of H dash we are having C dash of G dash, and next to C dash of G dash we are having D dash of F dash. So, D dash in bracket F dash, and at the end we are having point E, and we need to darken only the length from A dash to E dash. Now, in order to get the top view in the second position, what I should do is from these points I need to draw the vertical projectors, and from these points I need to draw the horizontal projectors, and I should get the top view in the second position. So, in order to get the top view, first I am going to write the vertical projectors from the front view in second position. After drawing the vertical projectors from these points, now I am going to write the horizontal projectors from the top view in first position. So, from point G, I am going to write the horizontal projector like this. So, where this G meets the vertical projector drawn from G dash, there I should mark point G. Similarly, from H, I am going to write one horizontal projector. So, if you write the horizontal projector from the point H, it will pass through F. So, I will extend this line up to here. So, this is the projector which is drawn from H and F. Now, so far we have satisfied two conditions, that the circular lamina is resting on HP on one of its corner, and also we have satisfied one more condition, that the plane is inclined 45 degrees to HP, which can be seen in the front view. Now, we should satisfy the condition that the top view of the diameter passing through the resting point makes 60 degrees with VP. So, here the diameter on which the lamina is resting is the diameter A dash E dash, or it is AE. So, this diameter AE, it should be inclined at an angle of 60 degrees with respect to VP. So, when you take any lamina and if you give inclination with respect to the vertical plane, so the angle of inclination, it can be seen only through the top view, and we are having the top view in HP. So, first what I am going to do is, I will take this line AE and I will incline this line AE. Here I have drawn a line which is inclined at an angle of 60 degrees, along which I need to place the diameter AE. So, first I am going to mark the point A over here, then I will mark the point E along the same line by measuring the distance AE. I am transferring the points. So, this arc, it represents point E. In order to incline the diameter AE at an angle of 60 degrees, what I have done is, so here I have drawn a line at an angle of 60 degrees. So, along this line, first I have marked point A. So, by taking this A as a reference, then I have marked the point E, which is at this distance. So, to transfer the point E, what we can do is, we can measure the distance of E from A in second position, and we can transfer it directly along this line. Then we know that the points B and H, they are along this vertical projector, and the points G and C, they are along this vertical projector, and the points F and D, they are along this vertical projector. So, in order to transfer these points which are there on this vertical projector, what I will do is, wherever these projectors, they are intersecting the diameter AE, there I have marked certain points. That is, the point where the line BH, it is intersecting the line AE, there I have marked point 1. Similarly, the point where the line GC, it is intersecting the line AE, there I have marked point 2. Then the point where the line DF, it is intersecting the line AE, there I have marked point 3. Now, transfer these points 1, 2, 3 along the line AE in final position by using the compass. So, measure the distance of A1 and transfer the point 1 here, then measure the distance A2 in compass and transfer the points along the line AE, and then measure the distance A3 and transfer it along the line AE in the final position. Then from point A, draw one vertical line from point 2 draw one vertical line, and from point 3 draw one vertical line. So, from point 1 we have drawn the vertical line. So, on the vertical line which is drawn from point 1, we need to mark the points B and H. So, from point 1, H is at certain distance. So, measure this distance and mark it over here. Similarly, from 1, B is at this distance. So, measure this distance from the compass and mark it along the line which is passing through point 1. Similarly, the line which is passing through point 2, it is carrying the points G and C. So, from point 2, measure the distance G and mark it along this line. Then measure the distance 2C and transfer it along the line which is passing through 2. Similarly, along the vertical line drawn from 3, we are having 2 points, one is F and another one is D. So, measure the distance 3F and transfer over here, and measure the distance 3D and transfer it over here. Now, join all the points by means of a smooth curve. So, this diagram is the replica of the top view in second position, but this lamina it is making an 60 degrees with respect to VP. In order to get the front view in the final position, what we should do is, from each point, that is A, B, C, D, E, F, G, H in the top view of the final position, we need to write the vertical projectors. So, from A I have drawn a vertical projector, from B I have drawn vertical projector, from D I am drawn vertical projector, from E I have drawn one vertical projector, and also from F and G I have drawn one vertical projector. Similarly, from points A dash, B dash of H dash, C dash of G dash, D dash of F dash and D dash, draw the horizontal projectors. Now, where the vertical projector drawn from A and horizontal projector drawn from A dash, they are going to intersect, there you mark point and name it as A dash. Similarly, the point where the vertical projector drawn from B dash and the horizontal projector drawn from B dash, they are going to intersect, there you mark point B dash. Similarly, the vertical projector drawn from C and the horizontal projector drawn from C dash, where they are going to intersect, there you mark point C dash. Similarly, the vertical projector drawn from point E and horizontal projector drawn from E dash, where they are going to intersect, there you mark point E dash. Similarly, you mark the points F dash, D dash and H dash, then join all the points. So, when you join all the points by means of a smooth curve, we will get the shape of the lamina in final position which satisfy all the condition. That is, it is resting on a point A on HP, and this lamina it is inclined at 45 degrees with respect to HP, and it is inclined at an angle of 60 degrees to VP.